outline exactly what we're going to cover. So we're actually going to extend it to 120 minutes. So you're getting 30 bonus minutes of ActivitySim tutorial that you didn't pay for. So that's just a little bonus today. And then finally, we'd like to ask that if you do have questions, and there are going to be, the way that we've structured this, as you'll see in just a moment, is that there are
You're muted, Joe.
Okay, thank you. Did anybody hear any of what I was just saying? That's great. Well, so I got like a bonus warm up. Now I'm totally at ease because I thought I was going to be all nervous. Well, welcome everybody to the ActivitySim.
Just the last like 10 seconds or 20 seconds.
Oh, okay. Oh, that was strange. Well, so I'm not sure how many of the ground rules you just caught, but we were asking people to be muted. We were throwing in 30 bonus minutes of ActivitySim tutorial that, again, you hadn't paid for. And then finally, with respect to any questions, we're going to ask that you post them to the chat box rather than raise your hand or anything like that. There are going to be opportunities after each one of the speakers to have at least a few minutes to answer some key questions. And then at the end of the entire tutorial, we're going to have a larger or maybe a bit longer question and answer session that can either cover anything that has been addressed in the Getting Started tutorial or in any of the earlier sections. So with that, I think I'll just jump in. I'm going to, let's see, share my screen with you. If you'll just, okay, share screen. And can everyone see my screen, I hope? Again, welcome to the ActivitySim tutorial. We especially also want to thank the Zephyr Foundation for making this possible. We had really had hoped to have the opportunity to do this in person, of course, this past summer, but we're thrilled to have the opportunity to provide this update to folks today. What I'd like to do during the presentation today is first give you a little bit of an introduction to the ActivitySim project. I know many of you are aware of the project, but just to cover some of the basic information about the project. Then we're going to talk very briefly about the agency partnership and how we manage the project, because this is, at least for me, a very unique and exciting project, because it truly is a very active collaboration amongst 8 partner agencies as well as AMPO. Then Ben Stabler from RSG is going to give us an update on the work that he has been leading with RSG, both as part of the current phase 5 work that is wrapping up right now, as well as talk to you about some of the work that's coming up in our next phase, which will run through June of 2021. Next, we'll get some implementation updates. We feel very fortunate that 2 regions have been actively, in addition to the development region, 2 regions have been actively implementing ActivitySim, including the Atlanta Regional Council and Southeastern Michigan Council of Governments. And so Guy Rousseau from ARC and Clint Daniels from WSP are going to talk about the ARC implementation. And then Jilan Chen and Joel Friedman from RSG are going to talk about the SEMCOG implementation. That'll cover about the first half of the project, the first half or the first hour of the presentation or tutorial. And in the second half, we're going to do a hands-on tutorial, which will be led by my colleague, Bhargav Asana. We'll walk you through how to get started using ActivitySim. Then at the end, again, we'll leave some additional time for questions and answers. So we'd like to talk first about the ActivitySim mission. And the ActivitySim mission is really, in its highest level, is to really create and maintain open source activity-based travel behavior modeling software that's really grounded in the best software development practices today, and that is available to the public and to other public agencies at no charge. And let's see. There we go. It's a little bit of a lag here on my side. The ActivitySim, as we have kind of progressed, we've kept in our mind that there are a number of kind of core principles that are guiding ActivitySim. Number one is that it's collaborative. meaning that what we're trying to get away from is, with the ActivitySim project, is having a situation where everybody kind of goes off and has their own software. And as innovations or improvements are made to one software, other agencies or other regions aren't able to leverage those improvements. And that really does represent an impediment to progressing. And so by having a common code base, while still admitting or acknowledging that there are, of course, necessarily regional specific implementations, we hope to basically allow ourselves to kind of leverage each other's improvements. Not unrelated to this is the idea that it's much more cost effective for us to be developing software jointly. We really want it to be a practical software that is a software that is both something that people who are just getting started using activity-based models can kind of use straight out of the box and get set up for their region and have a very powerful tool, as well as to provide more advanced users and agencies with the ability to produce reasonable results and reasonable estimates and forecast pretty easily as well. We really need it to be extensible. As we all know, there's lots of innovation going on in our industry, both with respect to kind of methods and analysis, but certainly with respect to what's happening in the real world as well. And so we need to be able to customize and extend to meet those needs. And then finally, none of us really likes to wait around a long time for any of these results. And so it's really important that it be high performing, that you can run really quickly on basic kind of computing resources that are available to all of us. That's from from the perspective of runtime and storage and all sorts of other things. As I said at the outset, what's really unique about the ActivitySim project, at least in my experience, is it truly is a partnership. Currently, there are 8 agencies that are contributing to the pooled funding for this project. We contribute those funds on an annual basis, and we give them to the AMPO Research Foundation. And AMPO has been instrumental in really making this project work. They have facilitated all the kind of coordination across the various agencies, and have been providing administrative support. I'm not going to spend any time in today's presentation going too much into the weeds of that, but if any of you have any questions about the kind of administrative aspects of the project, please don't hesitate to reach out to me or any of the other agency partners. By virtue of the fact that the agencies are contributing funding, we all have a role in the decision making, which is really exciting, and we've had some really great decisions. New agencies are always welcome to join us. And the benefits of new agencies is that you will be receiving, you'll be leveraging all of the resources that the other agencies have been investing for the past 7 years, but you'll also be able to help shape where we go in the future. The project management for this is really led by the project management committee. The PMC is actually staffed by a representative or representatives from each of the agencies that are kicking in funding. And the PMC really sets the development priorities and provides the kind of technical direction and oversight. And that means both kind of making sure that the existing kind of advanced state of the practice features are in there and implemented and are performant, but also helping to identify and develop new capabilities that are responding to the new kind of policy and investment analysis needs that we face today. As I mentioned in the last slide, we do this kind of on an annual basis. We meet very frequently, as a group. Typically, we've been meeting weekly, but then we have a process annually, and it usually takes a couple months for us to scope out ideas, understand what things people really need and want to see in the future, and figure out how to get that. And again, all of this is done collaboratively and by consensus. So with that brief introduction, hopefully, I'd like to hand it over to Ben, who's going to talk to you again about some of the work that he has been leading as part of this past years of work, as well as give you a taste of what the future holds for ActivitySim development this next year.
Okay, thank you, Joe. Go ahead and go to the next slide. All right, so I'm going to talk about the work program. ActivitySim work is done in phases. And so the first 4 phases, which correspond basically to a year of work, were done from 2015 to 2019. And in that effort, we talked, if some of you were there last year at the ITM session, or maybe it was the planning applications in Seattle or in Portland, I can't remember. We talked about our conversion of the MTC Travel Model 1 CT ramp model, and that was essentially completed last year, and that was version 0.91. And we've gotten more formal about our versioning system as we've gone, so we're starting to think about using versioning terminology and release planning as the platform starts to come together. So into phase 5, which is started last year, we've now been working, and we've completed most of that work, and we'll talk about that here in a minute. The idea is that this was released as 0.95 earlier this month, and as we look into phase 6, which is starting in the fall to be completed next summer, that will be version 1.0. And so go ahead, Joe, and I'll talk about phase 5 and 6. All right, so what do we do in phase 5? So remember, at this point, we've basically completed the conversion of the existing MPC activity-based model to ActivitySim. So we did a bunch of validation and verification to make sure everything looked good and had reasonable runtime. So we started making additional improvements. We've had a whole list of those, and I'll go through those in more detail now. So go ahead and go to the next slide. So we've made improvements to usability, inputs and outputs processing, reading and writing CSV files, HDF5 files, persisting mode choice log sums for estimating models or for accessibility calculators or things like that. The SEMCOG activity-based model project, which Joel and Gilan will talk about in a minute, they contributed the ability to write trip matrices, so to build trip matrices using user configurable expression files. The ARC project with Clint and Guy will talk about here in a minute. Originally, Travel Model 1 was 1 hour time periods, and that was sort of baked into the old software. And so as it got moved over, it got mostly unbaked, but it was still a little bit baked. So Clint helped completely unbake it. So now we have flexible time periods. So you can have 30-minute or 15-minute or whatever you want in the setup. We also added modeling TNCs and for hire vehicles. So Uber, Lyft, taxi. Those are now tour and trip mode choices modes. And we validated those, kind of lightly calibrated and validated those into the MTC example model. We added recipe books. So if some of you are familiar with Jupyter notebooks, these are a great way to kind of learning tools and ways to distribute examples in the Python community. So we added a few different recipe books, and Bargov in a little bit, we'll talk about the getting started Jupyter notebook. There's about 8 different notebooks. Some of you might be familiar with PopulationSim. That is a complete rebuild and improved version of some of the older population synthesizers that were built. We built that all in Python. It's all in ActivitySim format. That has been officially contributed to the consortium and is now maintained by the consortium. So go ahead and go to the next slide. We're currently working on a strategic development and contribution plan, and I think Joe highlighted the principles table. That was one of the things that's from the principles table, which is basically helping the team all better define how we will work together into the future. Because I think one of the fascinating and exciting things about this project is that collaboration and how the business model and all the agencies align scope, schedule, and budget efficiently in a shared code base. So that's the purpose of this document, is to help set that direction. Some of you might be familiar with DaySim, and DaySim has a neat functionality called model estimation mode, where you can basically take a DaySim setup and it'll write out all the logit estimation data files to re-estimate your models. And if you were familiar with CT ramp, the UECs or the expression files allowed you to write your own expressions, but they didn't necessarily integrate very well with estimation. And so there's been a pretty exciting task to do estimation functionality, which basically separates your data and your coefficients and cleans everything up really nice, and then writes all the data out so that you can then integrate with an estimation tool. And we've provided a bunch of estimation integration with Larch, and I'll show you that here in a sec. So go ahead and go to the next slide. Basically, the way the estimation mode works is you can read in your household travel survey files formatted in ActivitySim format, and it'll run through the ActivitySim models, and it'll join all of the simulation data and write out all the alternatives, so that then you can then estimate, say, an auto ownership model with ActivitySim's understanding of all of the information, and then read the results back into ActivitySim and run it. So this is really a way to clean up or just help you build an ActivitySim model, update the estimation, and do it in a nice consistent way so you don't have errors and duplication of information and whatnot. Go ahead and go to the next slide. We added a command line interface so that you can easily run ActivitySim through some quick little DOS commands. ActivitySim runs on Windows and Linux and Mac command line tools. One of the reasons we also created this tool was for a long time we've had kind of simple examples, and they're very small, but activity-based models and our example is the full Bay Area have a lot of data, and so we needed a better way to distribute examples as well. And this became especially important when we did the estimation integration, because we needed sufficiently high quality, comprehensive examples so that the estimation results were meaningful. So this also not only allows you to run ActivitySim, but also gives us a framework to distribute examples to users. SEMCOG and ARC deployments have also led to some improvements that we've incorporated into phase 5. So we made improvements to the multiprocessing. We are caching skims for reloading to save runtime. So if you're running the model a lot of times during development, it takes like 10 minutes to read the skims, all the skim data. So that way it's nice and fast. We've made some little fixes to expressions, tidying up things and so forth and so on. Go ahead and go to the next slide. We're still working on the multiple zone system and transit virtual path building support. So for those of you, this is kind of a deep dive into some heavy topics, but instead of just having models at one zone system at TAZs or zones, you can have multiple zone systems, microzones, TAZs, and stops for transit skims. And that allows you to use a different level of geography for different modes. So like non-motorized travel, bike and walk, can use a real detailed zone system instead of skims, and then card, which has a more aggregate representation, can use a different zone system. So you can imagine there's a lot of structural improvements that are needed to the software to make this possible. So we're still working on that, but this is inspired by some of the CG ramp model designs and the DASIN model designs out there. Go ahead and go to the next slide. Oh, I guess I kind of had a picture here. We're also adding transit virtual path building. So this is the idea of, instead of letting the path builder, the assignment tool, basically build your transit skims from zone to zone, you split your model system up into these different zone systems, and you model all your travel from microzone to microzone through a set of nearby stations or stops. And so the skims are station to station, and you have microzone accessibilities or costs to all the nearby zones. And then you let the demand model build the best paths through all the different alternatives. So you look at all the nearby access stops and all the nearby egress stops to the destination. You build composite utilities, and then you have some rules to pick the best or the top 3 or what, so forth and so on. So we're working on that functionality now. Okay, so go ahead, the next slide. So that's what we're doing in phase 5. We're pretty close to wrapping that up. We're looking towards phase 6 now, which will be starting pretty soon. All the estimation mode functionality has been implemented through all the tour models. It hasn't been implemented for the trip models, so we're going to finish that. We also are building more examples for all the estimation functionality, trying to, really one of the great things about ActivitySim, I think, is that we're not just building a model, we're also building an online platform that people can download and use. So we build a lot of tools and training materials and examples, and we take good care of those. That's an additional part of the effort. We're building a telecommute model and a transit pass ownership model, and those will be done in cooperation with the SEMCOG project. ActivitySim, always is working on performance enhancements, so that task seems to always be in every phase. We are going to be building some functionality to improve the test system and the management of multiple examples. So we've principally been working for the last few years with just the MTC Travel Model 1 example. And now that we have SEMCOG ARC and we're going to have multiple model designs in different regions, we need to continue to build a better system to take care of all that. And in each work order, we have sort of more input checking, error handling, data management stuff that'll be done. And I think it's new this year, but we've had a little bit the last few years, but we have an explicit, sizable amount of maintenance support to provide support to our agency partners and other users of the platform. And so this we believe really results in, version 1.0, which is planned to be released early next year. So go ahead, and I think that was it for me. Oh yeah, and then that's 6A. Okay, so that the phase 6 has been split into 2 phases. Sort of 6A, which is sort of finishing version 1, kind of existing functionality, and then 6B is looking to the next round of work. And so this is where we get into newer kind of design questions: vehicle tracking, AV modeling, AVs, escorting, and other sort of model design questions. I think at the same time, we also went through an exercise the consortium did to prioritize and brainstorm a lot of features and decide what else to put in. And a couple other things that were prioritized were kind of automation of model calibration functionality. And I think Joel in a little bit is going to show some, Joel's back here in case you didn't see that. He's in the queue behind me. Some work they've done for SEMCOG that took advantage of some of the work we did for the estimation functionality to really kind of clean up the way data is managed to make automating calibration a lot easier. So, and then as usual, maintenance and support and sort of more reporting improvements or configurations to make it easier for the user to use it. So that will result in another release later this summer. Okay, I think that's it for me. Back to you, Joe.
Yeah, so I wonder, Bhargav has been monitoring the chat. I think we have maybe a minute or two if any questions have come up for Ben about anything that he has described about the phase 5 or phase 6 work. Are there any questions, Bhargav?
Yes, there's a couple of questions. One question is, how is the fee that needs to be paid to join the ActivitySim consortium determined?
Sure. Well, maybe I'll handle that. So right now the partners have been contributing $35,000 per year. And that goes into a pooled fund. So for this most recent year, that led to about, when we take off some admin and overhead, about between $200,000 $250,000, almost $250,000 to program for ActivitySim development work. Thus far, there's been far more work than we can possibly accomplish in any given year. And so we have just been contributing this $35K amount every year. I think it's the intent of the partners to continue to deposit or pool these funds via AMPO. If at some point we find that our development needs are somewhat attenuated or diminished, then we might consider at that point, or with an expansion of lots more agency partners, there might be an opportunity to bring that contribution down. But at present, I think we're still intending to maintain annual funding per agency at that level.
All right, there are a couple of questions related to the estimation mode. One is, model estimation usually involves testing many different specifications. What's the process for doing this? Does one need to modify the specification in ActivitySim for every test?
Yeah, so the model estimation functionality is a couple different things. One thing we did was we built what we call an estimation data bundle, an EDB. And so that is ActivitySim basically cleanly differentiates coefficients from data expressions in 2 different files. And then when you run the model, it takes your household travel survey and it joins all the data that's required by the expressions, and it writes out the estimation data bundle. So this is your survey appended with the information you need for estimation, including the choices you made and whatnot. That was specifically designed to be kind of a flexible open format so that you can then do what you want with it. At the same time, we've also integrated it with Larch, which is a modern kind of Python estimation package developed by Jeff Newman. And that then has been integrated to read the estimation data bundles, run Larch, generate your estimation results, and then write the results back, basically update the coefficient files, and send those back to ActivitySim to rerun it. So the process of doing this is to use those tools right now out of the box, or if you want to build your own tools to do so, you can. And I think this is a question from Rosella, and I think Joel, you might talk later a little bit, because I think you guys have done some work to convert the data into a logit format as well, the data bundles. Maybe I'll just follow up real quick with the second part of Rosella's question. Has there been any interest in implementing ABMs that follow a structure substantially different than CT-RAMP1? There definitely is. And how will it be managed? That's a good question. So that's part of the plan of the strategic development plan, is to help provide guidance for that. I think that's something that the SEMCOG and ARC projects will start to diverge some more, but as there's more divergence from that, you know, the goal is to keep all those in one code base.
And with that, I think we should probably, thanks for the great questions. There's actually a lot more to talk about on that thread. But in the interest of we have a lot of other material we want to cover, so I'd love to move on to hear from Guy Rousseau from ARC and Clint Daniels from WSP to talk about their work implementing ActivitySim for the Atlanta Regional Council.
Yeah, thank you, Joe. So I'll go ahead and get us started, and I'll move it over to Clint a little bit. But I want to go to the following slide. So what I want to say, just to give a background, historical perspective as to why we chose ActivitySim for this prototype. Well, it all started about in 2007. Y'all may remember this special report 288 from TRB, National Academies of Science, that determines state of the practice and problem and modeling. And at the time, one of the finding, and I got on the slide here, is, you know, there's no need to replicate efforts amongst MPOs. So we figured, you know, why not create some kind of a arrangement, joint agreement between MPO, state DOTs, whomever, to put our resources, our efforts together towards a common platform. So this is where at least the idea, the thought started. And then over time, back in 2007, ARC worked with MTC on this collaborating effort, a joint effort for an ABM. That was the very first, so one of the first CT-RAMP version. That was, of course, Java version at the time, codenamed Baylana, Bay Area, Atlanta, right? So that was at the time with Jim Hicks and, of course, Chuck Purvis at MTC and others. And that concept more or less matured over time. And if you want to know more about the actual historical aspect of ActivitySim, there's a reference here on this slide. You can look into it later. But back to our goals and objectives at ARC, we just want to basically look into our full implementation of ActivitySim, and then always, you know, remain objective and careful before jumping into something. Compare pros and cons with CT-RAMP, and then decide whether we want to go forward, which we probably will. But you know, we want to have empirical evidence and such before we jump right into it, of the ActivitySim model application. Once we determine that's the way to go, then we're going to proceed with, and based upon our forecasting needs, of course, we're going to look into the actual production-ready ActivitySim for ARC, and then use that for our future model updates and so on and so. We've already used CT-RAMP on many plan updates, tip amendments, that sort of thing. So we already have a model up and running in production mode. But clearly, ActivitySim is the way to go in the future. It's more above and beyond just translating from Java to Python. There's a whole lot more to that process. And so at this point, I'd like to turn it over to Clint.
Thanks, Guy. So just to reiterate from what Guy was just suggesting, I think what Joe and Ben have both said as well is that the concept of ActivitySim is really this notion of one build, many implementations or many deployments. And you know, where this comes from is you know, having one set of code that can be deployed across multiple regions, and then calibrated to the local specifications of that region. And so, you know, the key really of the ARC implementation is that it's not some fork or spur of the main ActivitySim code base. It is the same code base. We do not run any customized code thus far for ARC that isn't in the AMPO ActivitySim repository. And so Ben had mentioned this a little bit earlier, and I'll come back to it later, but we've been actively working with the consortium via our ARC contract at WSP to put in pull requests and suggest enhancements that has led to a pretty good working relationship with AMPO, with the consortium, with RSG, in terms of pulling those enhancements in so that they can be used by the larger community. So the goals of this really are then to reduce the maintenance and innovation costs associated with transportation modeling, so that not everybody's having to spend money and time doing the same thing over and over and over again, which has been some of the problems within our industry, and to really focus on building software to implement for the region, for any region that can then just be customized down by parameter files and input files that are pretty easy to manipulate. And then again, no changes to those local compiled libraries. So again, just this reiteration of the fact that there will, if done properly around the country or around the world, there wouldn't be specific ActivitySim software installs, but specific calibration setups with a common set of code. So next slide. So with that in mind, what ARC hired us to do last year was to go through where the code base for ActivitySim stood kind of in spring of 2019. So right before I think the consortium was done with the phase 4 implementation that Ben had mentioned earlier. And so going through and reviewing, how far along it was, whether or not the software was ready for a practical implementation at ARC, and evaluating that to make sure that we weren't just going down a path of implementing something that wasn't ready for prime time. And so I think what we determined last April was that the software largely had been developed in a way that could support, at least our perception was at the time, that it could support ARC's implementation. And then was it worth going down the path of then actually trying to implement the ARC model in ActivitySim? And we decided that yes, it was ready for that, and we should move forward. The other 3 questions on here in terms of, is it fast, is it flexible, and is it innovative? Those will be determined as we finish off the complete conversion later this year. I will say just on one of these, in terms of, is it flexible? I think the answer there has been a resounding yes, at least in my mind. And I think some of the pull requests that I'll talk about in just a minute have been a testament to how flexible the software is, and in terms of being able to share information across regions back and forth. So next slide. So as of right now, we have converted 12 of the 16 primary models within the CT ramp implementation. So on the right here is kind of the high level overview for those of you who have CT ramp implementations. You've probably seen this chart or something like this, either in our proposals or in your own documentation. We've worked our way down through tour mode choice, and we're currently working on the at-work sub-tour models. And we've probably spent, I don't know, I'd say at this point, when you look at it over a dedicated span of time, it's probably been one or two people working on this full time for about 3 to 4 months when all said and done. I mean, it's been spread out over the course of a year, but when you look at total FTEs, it's probably been 3 or 4 months of total FTEs in terms of getting this far. We've issued 3 pull requests, again, that I'll talk about in just a minute, to make some enhancements. Ben mentioned one of them earlier in regards to flexible timing or time of day, hours versus half hours versus 15 minutes. I did put a little graphic down on the bottom left just to show that the model does produce what I would consider somewhat reasonable results. We're still going through the process of double checking all of the calculations and other information that's coming from ActivitySim. But on the bottom left, there is a simple chloropleth map of the outputs from the auto ownership results. So, less auto ownership in the core of Atlanta and more auto ownership as you move outside. So, we are seeing things that look reasonable, at least at a cursory level, as we move through the as we move through the conversion efforts, and we'll double back through and do everything in a very meticulous way as we move forward. So next slide. So as I was just suggesting, and I think Ben had alluded to this before, when we're converting over CT ramp implementations, at least, most of the work effort has been focused on the conversion of UECs, utility expression, I forget what the C stands for, but basically these are the parameter files of a CT ramp implementation. They are all loaded into Excel right now, which at one time was a good thing, but as we've moved more and more towards GitHub and other text-based editors, the notion of having your expression files stored in a binary format have maybe reached their limit in terms of version control and checking things. And so we've converted we've converted over those 13 models that I was talking about into these CSV specifications. And if we go on to the next slide, I've got one of them kind of blown up here. And so I think the biggest issue for folks considering the transition to ActivitySim or considering, implementing ActivitySim as their first step into activity-based modeling is the biggest learning curve I think that we've encountered thus far is the notion of what I loosely refer to as linear expressions within the CSV model specification. So I've put two here from, I think this is the auto ownership model, maybe. And one of them is pretty easy, the one on top. So distance squared, there is the skims, free SOV free skim midday squared. So that's the simple specification for squaring the value of the skim reference and then applying your coefficient, in this case, 0.000135. So that's pretty straightforward. On the bottom, though, is a little more complicated one where you're using a set of NumPy expressions. And so NumPy is a scientific Python library for doing mathematical operations on matrices or series in a very efficient manner. And what this allows you to do is rather than looping over your values in your matrix, which can be really slow, it focuses on doing those calculations in a matrix, basically, which is computationally much faster. The challenge with this, though, is that lots of folks who come to the transportation planning space or the modeling space often are used to dealing with loops and traditional for loops or if-then statements, and this really changes that paradigm. Construction to a single line of code to iterate over large matrices. And so, once you get the hang of it, it goes pretty fast and it's really elegant once you get the hang of it. But I will say, expect as you move into this framework to spend a little bit of time here getting a handle on this concept in your utility expressions, but well worth it in the end once you've got it down. Next slide. The other piece that we've been working on with ARC is one of the ARC implementations. What they wanted to do was to make sure that as they moved from CT ramp to ActivitySim in this prototype evaluation, that the answers they were getting were the same. And there's two ways primarily that we've come up with testing that. One is, does the math all work? And is, ActivitySim calculating things appropriately? And so in this particular instance, we've been working through a system where we can mimic outside of ActivitySim the way that those expressions should be evaluated. And then we compare those to the ActivitySim outputs to make sure that we get the same answer from just a pure arithmetic answer between the two frameworks. If you go on to the next slide, the other way that we've been looking at this is at a final step level. This is a simple one where there is no stochasticity in this particular one that we're looking at, but this is accessibility calculations and looking at how ActivitySim then does the overall calculations. And in some cases, I don't know if I have it on my next slide or not. The choices that are actually being made. And so What you can see between these two slides, I think all of these line up pretty well. I think the top right one, you'll see 4.89 versus 4.88 in the one below. That has been one little, I wouldn't say it's an issue. I mean, these are small differences, but in terms of the way the floating point numbers are handled between Java and Python is slightly different, so you get some rounding variation. We have found some instances where CT-ramp just clearly does things differently than the way that ActivitySim does. And I think, as you move through this, if you are converting from one model to ActivitySim, is just to be aware of the fact that in some instances, things just may be done differently, and you'll have to make a value judgment as to whether or not you agree with how that's being done differently. And thus far in the ARC case is, noting those differences. I think really the only place we've noticed a critical difference is in the way log sums are calculated, noting that and moving forward. And, I think in the case of ARC, it'll be up to them to decide whether or not that's an acceptable difference that they're willing to live with. But, so far it hasn't really seemed to have too much of an effect moving forward. So next slide. So then the next point here is on collaboration and flexibility. So, I think what was unique from the ARC perspective is up until ARC moved forward with developing this prototype, it had largely been the consortium working with RSG to develop the MTC prototype as well as the core code base. And so, everybody who's been working on this project has done great work to date, but there really hasn't been a lot of outside of collaboration. And so I think, having ARC come in and do a prototype has really brought forward some issue. They're not issues, have brought to the forefront, how different organizations collaborate moving forward. That weren't really an issue when there wasn't, an outsider at the door asking, can you change this? Can you change this? But what I will say is that, working through this process, one of the things that was developed is, you'll see it there on the bottom left, is this review criteria responses. So the ActivitySim consortium, I think, came up with a list of 8 or 9 questions with each pull request that you have to answer in terms of, how does your pull request affect the core code? Is it backwards compatible? With this first one here, this was our first one where we put in that time flexibility. We didn't, in our initial pull request, we didn't build in backwards compatibility. And Joe and Ben rightfully pointed out that, we should make sure that this continues to work and we don't break something that that somebody else had in there. And so we went back and built in backwards compatibility. I think Ben has subsequently made a pull request from SEMCOG that also focused on backwards compatibility, which we appreciate because we were moving forward with the ARC implementation. So there's been good collaboration here. And I think the real key of this is that because of this great collaboration is we haven't had to fork off of the ActivitySim code base. We've been able to maintain this one build, many deployments within the ActivitySim framework. And so from that perspective, it's been a really positive experience moving forward. Next slide. And then the last thing that I just want to highlight here is that, what will be key over the next couple of weeks is ARC has a model that isn't in the core MTC modeling framework. So it's the parking location choice. This is added for Sandag and then eventually deployed in a handful of CT-ramp implementations in Miami and Atlanta and other places. So I've been working on writing the code for this over the last several days, and we'll be probably putting in a pull request sometime, not this week, but sometime next week on this. And what will be really interesting here is this is not just a minor kind of tweak to an existing framework. This is a whole new modeling system. And so it's going to really raise and force us to think about how we do model testing in terms of data getting put back into the framework for all the testing procedures. How do we ensure that it works across a broad range of users, as well as does everybody else like my coding style at the end of the day? And that'll be interesting to review as well. And so this will be the first non-sort of consortium built component that'll be going back into the model. And so, at least at WSP, we're really proud of the fact that we're able to contribute to this framework via the ARC model. And really think through these processes with the consortium in a deliberative way. So with that, I will hand it back to Guy to finish off, but thank you. Oh, one last point is, if you do want to look at our code, it's been very transparent, so feel free to go email me or go on to GitHub and just look for the ARC ActivitySim implementation on GitHub, and you'll find it on the WSP GitHub site. So with that, now I'll turn it back over to Guy.
Thank you, Clint. So just to wrap it up real quick. So we remain very, very optimistic for the future, needless to say. Not only speaking about for the RC, but I guess with the entire ActivitySim group. So we want to continue to grow a consortium over time with additional contributors, whether it's other MPOs, say DOTs, consultants, whomever. And I think, Joe, at some point, you're going to talk about the bench procurement and upcoming task orders. We finally have a common language for not only for trial element modeling, but also for policy analysis, right? So we want to compare different policies, say in the Southeast, in Atlanta, and then on the West Coast, and we're able to compare in a common platform. And then last but not least, it's a benefit. You would all benefit from being part of the larger community. Basically, it's like a co-op, right? So you join the co-op, you join our group, and then you right there, that red square bottom right corner could be you, right? Could be the next MPO, the next state DOT, the next consultant to join our growing family. So next slide, and then that's just our, Joe, if you want to go, yeah, this is our contact, so feel free to reach out to us. And then at this point, we'll take questions, comments, feedback. Thank you.
Yeah, thank you, Clint and Guy. We have about maybe a minute or two. So if there's maybe we should start with one question, Bhargav. Is there anything that's coming in the chat that could be directed to Clint and Guy about their experience?
There have been several questions about the flexibility of the model specifications, but I think most of them have been answered by one of our team here. Okay,
great. Well, if additional questions come up, we hopefully, if we stay on schedule, have some time reserved at the end. And if folks haven't had a chance to ask their question, we can maybe be able to loop back to it then. With that, let's transition over to Jilan Chen from Southeastern Michigan Council of Governments and Joel Friedman to talk about their experience implementing ActivitySim in the Detroit region.
Thanks, Joe. I think Jilin's going to kick us off here with an introduction to the project, and then I'll fill in some details. On the agenda today, we'll cover motivations for implementation of ActivitySim. We'll speak to project phasing and schedule. We will cover the data that we used for development of the model, modifications that we made to the model, and some tools that we've developed and contributed along the way. We'll cover some of the initial results of the model and some lessons learned. Jilin?
Yes. Yeah. Hello, everyone. My name is Jilan Chen. I'm the leading modeler at SEMCOG for this model development project. SEMCOG area covers kind of 7 counties in Metro Detroit region, total around 1.9 million household and 4.7 million population. So this project will be developing SEMCOG's first activity-based model. So what has motivated us to adopt ActivitySim for SEMCOG's first ABM? Let's look at the 2 project goals we have for this model development. One is to develop a practical, functional, and usable activity-based travel model. What do we mean by that? Is we want the ABM to be fully calibrated and validated using SEMCOG's local data, have a reasonable runtime, and the model will be well documented for both model developers and end users. Another project goal is ABM is capable of addressing key policies of interest for SEMCOG's planning needs. For example, the activity-based model should include all highway and transit modes operated and proposed in SEMCOG region. It should also be able to respond to different land use development, cover the travels by university students, have the abilities to perform analysis on various policies, such as telecommuting, transit pass pricing, and aging population. With these two project goals in our mind, SEMCOG joined the ActivitySim partnership in 2018 and engaged in the team meetings, discussions with the partners and the consultant. We were grateful for the team's open communication and the support from all team members. So we feel that the ActivitySim has advantages due to its coordinated efforts of the platform development, best practices from advanced ABM users, and the latest software design using Python. So by the time SEMCOG started this project in the fall of 2019, ActivitySim made enough progress to be used as our base for SEMCOG's ABM project. We understand there will be learning curves and challenges since we are the first one to totally adopt this ActivitySim. However, we believe by doing so, we can benefit from the experience and good practice developed into this ActivitySim from the community. And also we can contribute back to the community with SEMCOG's model development effort. Next slide. Since this is SEMCOG's first activity-based model, SEMCOG decided to use the two-phase approach. The reason for that is we want to have a working activity-based model of SEMCOG region for SEMCOG staff to use as a learning platform to get familiar with its functionality. It can also be used for the project team to assess the strengths and the weakness of the ActivitySim model to better inform our model enhancement in next phase. Our phase 1 involves reviewing SEMCOG's existing model structure and all data available for model development, configuring the ActivitySim for SEMCOG region using MTC example with minimum changes. The expected completion of this phase is about 1 year. We started this project last October. So currently we have, ISG has helped the completion around 90% of this work in phase 1. So we are probably 1 month behind the schedule. Not too bad, I assume. So phase 2, informed by the findings from phase 1, will involve more solo model calibration and validation, model enhancements, and developing new features to address SEMCOG's planning needs. This phase takes another 1.5 years. So the entire project will be completed by the spring of 2022. Now I would like to hand over back to Joe for more detailed discussion over the progress we made so far for this project. Joe, it's yours now.
Thanks, Jillian. Okay, well, so in contrast to ARC that already had an activity-based model, now we're talking about a new model for a region that's switching from a trip-based model. So obviously this is more akin to a sort of typical model development project where we start with looking at observed data and coding it to be consistent with the modeling platform. In this case, we have a 2015 household travel survey that covers about 12,000 households. It's mostly a traditional diary, Katie type survey with a GPS subsample. There's also recently conducted onboard transit survey of about 18,000 trips, about 1,000. There was an additional sample of about 1,000 people that were included in a tour sample. They basically reported all of their travel on a given day using smartphone-enabled GPS-enabled smartphone devices. And from that, we're able to glean some information about mode switching on transit tours. We're also using census data as a calibration source and also as a source for our synthetic population. Next slide. Okay, so if you're contemplating moving from a trip-based model to an activity-based model, you might be wondering what kinds of data sets do I need? What do I need to implement ActivitySim? For the purposes of the phase 1 model, we are staying mostly consistent with existing data available at the TAZ level that's being used in the current SEMCOG E7 trip-based model. One additional attribute that we've asked for is school enrollment data. So K through 12 and university enrollment. This is data that's publicly available, but it does need to be geocoded and forecasted into the future at a TAZ level. And that's been done. I don't think that was a major lift for SEMCOG. Activity-based models, ActivitySim relies on a synthetic population. This is a disaggregate sample of households and persons, a representation of the actual population. SEMCOG had, previous to the ActivitySim deployment, they had a population synthesis procedure as part of their land use model, and we've adopted that procedure in the phase 1 implementation. At the same time, SEMCOG has been testing the ActivitySim population synthesizer called PopulationSim. That was software that was contributed by Oregon DOT to the consortium, and is in the same sort of format with Python and Pandas that the ActivitySim platform is in. And they may replace that synthetic population with PopulationSim, as it does fit marginal distributions better and is a shorter runtime. Next slide. The network procedures are mostly consistent with the trip-based model. There are some differences in time periods that need to be accounted for. Trip-based models tend to use production attraction format for transit skimming and assignment. That was no different for SEMCOG, whereas ActivitySim requires origin destination format. So there were some modest changes to the skimming procedures required to support ActivitySim. ActivitySim reads and writes OMX, open matrix format files. So Transcad supports that. So we had to make a minor change to the code to write and read those files. It's probably no surprise that the transit network is very different in the SEMCOG region compared to MTC. MTC has something like 30 transit operators, and there's quite a bit of competition between transit modes, whereas SEMCOG has less than 200,000 transit trips and only a few transit operators and very little competition between transit modes. So we simplified the SEMCOG the mode choice model from MTC Travel Model 1 that we're using in SEMCOG. We simplified the model structure. We actually did add or differentiate now in SEMCOG Park and Ride from Kiss and Ride that wasn't differentiated in MTC Travel Model 1. So in some ways, we made the model structure a bit richer. There was a question earlier about how easy or difficult is it to change modes in the model. It was fairly easy to change mode specification. It's a very open framework in that sense. I would say the only catch is you do need to make sure that if you change the alternatives in a model that you do so consistently throughout all of the models, because one model might depend on the outcomes of another model. So just be careful. Next slide. Some other modifications required to implement ActivitySim. The land use categories are different, as you might expect from region to region. So it is important to make sure that size terms in destination choice models, for example, are reflect the land use data that you're using, the categories of employment. We did modify those in the phase 1 models. I talked about a lot of these scripting steps. One thing that to keep in mind if you're moving from a trip-based model to ActivitySim is oftentimes you have a mixture of resident trips and non-resident trips in your trip-based model, and you will need to make sure that your non-resident trips are sort of broken out from your resident trips and modeled in addition to ActivitySim, which is really focused on resident travel, and then add everything together before assignment. Next slide. Okay, so you might be wondering about model runtime. So the model, it covers almost 2 million households in the base year, about 2,900 TAZs. We currently have it running for 3 feedback loops where we change the sample rate, increase the sample rate in each feedback loops. We're running this on a server with 12 physical cores, 24 total, and that should say 128 gigabytes of RAM, not 28. Sorry about that. 128 gigs of RAM. The whole model system takes just under 14 hours from start to finish. That's about 8 hours for ActivitySim, and the rest is for skimming and assignment and aggregate models. And about 4 hours for 100% sample of almost 2 million households. Now, we could reduce the runtime by increasing RAM because ActivitySim is threaded. So the more RAM you have, the more threads you can run simultaneously, and the shorter the runtime. Next slide. Some tools that we've developed along the way. We've been developing at RSG a visualization software. It's actually written in R, and it reads outputs from your activity-based model, and it can read coded travel survey data as a point of comparison, or it can read model results from a baseline model run. And it creates a static HTML file that the user can then look at, query, and see differences in model results, baseline versus build, or model versus survey data. We'll share some results of the current model in a minute here, but that is a tool that we can contribute to the consortium, and other members can use it as well. Next slide. We've also been developing automated calibration scripts for mode choice. We find it's pretty common to end up calibrating mode choice multiple times as you look at things like traffic assignment results and transit assignment results, and you get new survey data, or you've changed the model specification. And so this seemed like a good place to start for automating some of the calibration procedures. So anyway, this is all done in Jupyter notebooks. It reads the results from an ActivitySim run and targets that are created from a survey data file, and creates some plots of the results, adjusts alternative specific constants, and writes those constants to ActivitySim input files, and then the coefficient specifications, and runs ActivitySim iteratively, adjusting the constants automatically until the user specified number of iterations is reached. Next slide. Okay, so here's some results from the initial deployment. Just keep in mind that these are results with very little calibration. We did calibrate tour mode choice models. We did adjust size terms, and we re-estimated auto ownership. But other than that, everything is exactly the same as the MTC model. Here you can see a reasonably good match between tours per person. It's a little blurry, sorry about that. The trips per person is a bit low compared to survey data. I think that's mostly because the MTC survey upon which the models were based is a traditional diary survey, whereas the SEMCOG data has this GPS subsample, which is a little bit better at picking up intermediate stops and adjusts the expansion factors to account for underreporting. Next slide. This slide just shows the auto ownership model before re-estimation and then the re-estimated match, which is quite good with no calibration compared to survey. This is actually compared to census data. Next slide. The mandatory location choice models matched very well compared to survey data, with the possible exception of university travel, which is probably a bit biased in the household survey, given that it didn't capture group quarters. Slide. Tour rates per person looked pretty good right out of the box. Next slide. As did time of day, although the SEMCOG region does appear to be a bit earlier in terms of travel than the Bay Area. Next slide. And this just shows highway assignment, percent root mean square error, about 41% for the trip-based model overall, compared to 42% for ActivitySim with no calibration, which is pretty impressive given that, you know, we haven't done anything to the specification other than, you know, some modest changes to mode choice and sort of right out of the box running the model. Next slide. Okay, so what are we planning for phase 2? Well, the ActivitySim consortium is working on microzones and transit access points for transit point-to-point calculation. So we're planning on adopting that, and SEMCOG is working on development of a microzone system and network enhancements to support that functionality. We're going to adopt the TNC modes from the consortium. We're planning on adopting half-hour time periods from the ARC contribution, and we're planning on contributing a number of features back to ActivitySim, including autonomous vehicles, the telecommute model, transit pass model, and disaggregate accessibilities, which is another topic that we don't really have time to talk about here. Next slide. Okay, so lessons learned. I think, you know, it was pretty surprising how reasonable the results looked, even given the pretty significant differences between the San Francisco Bay Area and Southeast Michigan in terms of population and density and urban form. So I think in general, we're pretty pleased with the transferability of the model so far. It was reasonably easy to make changes to the code in terms of changing mode specifications and so on. The mode choice model wasn't quite as transferable, but it was easy and flexible in terms of code changes. We have reasonable run times. I think the consortium is planning on improving the run times even more, so we look forward to that. I would say one thing about transferring any model is you need to pay special attention to what we call special travel markets, and so unique differences between regions. For example, in Michigan, university students, in Southeast Michigan, university students make up 30% of transit ridership. That's important. There's a transit mode called People Mover, which serves downtown Detroit and has pretty unique drive auto access component. So that's going to take some special consideration. But overall, I think we're very pleased with progress we've made so far, and the ability of the software to be modified to transfer it to the SEMCOG region. I'm happy to take any questions.
Well, Joel, thank you so much for that presentation. We're running a little bit late. And so I think what I'd like to ask is there's been a lot of activity on the chat. I would encourage people to still ask questions and folks are free to reply. But in the interest of time, I think we should transition into the second half of our tutorial today, which is having Bhargav Asana walk us through the getting started with ActivitySim notebooks. So Bhargav, are you ready to take the wheel?
Yes, Joe.
Not to imply any modal bias there.
All right, thanks, Joe. I'm Bhargav Asana. I'm a transportation modeler at the San Francisco County Transportation Authority. And in this part of the session, I'm going to walk us through setting up and running an example model run using ActivitySim, show the directory structures and files required for a typical model run using ActivitySim, and also highlight some useful features of the system, such as multiprocessing and tracing. The questions, as with the previous session, will be handled through chat. So please feel free to type up your questions as you may get them, and we will address them as needed. So last Friday, all the participants received a link to the Getting Started documentation page of ActivitySim, which is what I have currently shared on my screen. We hope that the instructions were fairly straightforward to follow. And if you did not get a chance to run these, you would still have access to this recording to follow along later. But the first step is to install the Anaconda distribution of Python. That is what we recommend using with the ActivitySim. And this is a very popular distribution, and so you may already have it installed on your system for other purposes. The next step would be to create a virtual environment for installing the ActivitySim package and its dependencies so that they don't really interfere with any other Python-based tools you might have on the system. Installing the dependencies is just a few conda install commands, or you can alternatively also use pip. And then finally, you just need to install the ActivitySim package using pip, just as you would any other Python libraries. Scrolling down further, you would see that we have a set of Jupyter notebooks that Ben had referred to earlier, with a typical recipes to just get started with using the ActivitySim platform. And I'm going to go through one or two notebooks in this session. And the first notebook is the Getting Started Jupyter notebook. And we have a link to that in here. And if you go to that, it's going to take you to the ActivitySim repository on GitHub. There are several other notebooks, recipes such as adding a new mode or changing the specifications of model, but we hope that you can easily follow them with this introduction. Our main aim is to just make you feel comfortable just trying out the system without worrying too much about creating the inputs that are required for running the model. So I'll now go over to the Jupyter, the Getting Started Jupyter notebook. And since I've already installed ActivitySim, I'll just skip this step. But the first step after that is to set up the example. And this makes use of the command line interface feature that Ben had talked about earlier. And all this command is doing is creating an example called example_mtc and pulling all the data related to that in a folder called example. So let me go ahead and quickly run that. While this is running, I'll quickly go back to the repository to show that we also have other examples. If you would like to go through them, there's an example manifest file in the examples folder in the repository that lists all the different examples that are available for you to test the system out. We will be using the example MTC example, which is just a small 25 zone example and a few thousand households. And we also have the full MTC travel model run example with the full system of zones and the 2.8 million households in the region. And there's a slightly smaller example than the full, which has the data for San Francisco County only. So turning back to the example setup, just a couple of commands. It just takes a few seconds to pull down the small example. And I'll quickly show the directories that got created. So in the example folder, what it has done is pull down the configs or configurations needed for running the model. This has a whole bunch of files. I'll go through some of the details in a bit. In addition to that, there is a data folder, which is the input data folder. And this mainly has the land use inputs, the synthetic population, and the skims inputs. And finally, there's the output file, which will eventually write out all the the simulated outputs of the model. So let's take a minute to look at the inputs that are needed for the model. The main model expressions and settings are found in the config folder that I just showed you. And the primary input settings are in a file called settings.yaml. Which I have up on my screen now. And this has, in addition to all the input files that are needed to run the model, a few global settings. So starting with the input tables list, the primary inputs are a households table, persons table, and then the land use table. And we need to specify what are the index columns, the household ID, the person ID, and then all the other household, person, and land use attributes at the TAZ level, what columns need to be retained for the simulation. There's also the skims file, just one skim file in open matrix format, which is based on the HDF5 data standard. And we've also had an introduction to this format in a previous webinar, I think a couple of months back, on data standards, industry data standards. For the purpose of this tutorial, we'll just be running a small sample of 100 households. We'll be turning off other detailed features such as shadow pricing. But then we'll keep the tracing on because I want to show you how easy it is and how detailed the tracing is done at a household level in ActivitySim. The model section has all the different model steps that are going to be run in sequence to simulate the choices of all the synthetic population. It starts with importing and computing some additional variables, going on to the long-term choice models of work location, auto ownership, and then moving on to the day pattern level models, generating tours, and then subsequently going on to the trip level models, trip destinations, trip mode choice, finally writing out the data dictionary skims and the output files and trip matrices. There's a section for specifying the names of the files and the formats. This just specifies that they're going to be output and flat files, but there's also the option of putting them out in the HDF5 format. A few more global variables and definition of the skim time periods. As pointed out earlier, you can see how it's flexible to define multiple time periods and their ranges. And finally, some more global variables with the values of time in here. going back to the notebook quickly, let's look at some of the input files. And again, there's just a few commands to pull up some of the inputs. We already looked at the settings YAML file, which had mostly the global settings required for running the model. In addition, the config file also has a set of files for each of the model steps. And I'll probably go through just a couple. Let's look at the auto ownership model, for instance. Each of the model steps has a YAML file for the model specific configurations. It also has a specification file where all the utility terms are specified. And then finally, a coefficient file to specify the model coefficients. So quickly pulling up the auto ownership YAML file. This doesn't have a whole lot in it. Mainly, it points to the specification file and the coefficient file in addition to specifying the choice model type. In this case, it's an MNL and a few other constants. The tour mode YAML file probably has a bit more, which I will pull up right now. As you can see here, it is a nested logit, and this has more information about the nesting structure for the model and a few more constants that are required to calculate the utilities. In addition to the model level configuration file, we also have the specification, and I think a lot of you were also interested in looking at the specification, which just has listed all the different terms in the utilities. And I think Clint had shown some of these before, where you have in the rows the utility terms. There's a text description also of all these utility terms and the actual expression that will be used by the system to calculate all these values. And then additional columns for the different alternative. In this case, since it's the auto ownership model, we have alternatives of 0 car households and going up to 4+ cars. And all these coefficients have been pulled out into a separate file. And that's what the auto ownership coefficient flat file has in them, the values of all the coefficients. And these are designed so that they can be updated by the estimation mode when run in ActivitySim. So with that, I'll just go back to the notebook to look at some other input data that we talked about earlier. To start with, this is the land use input file, and it's just a file with a primary key as the zone ID, and then all the zone related information fields that are required by the model simulations are like the total households, employed residents, employment by the different industry sectors, and school enrollment, etc. We'll take a quick look at the households and the person file also. Again, just the primary key is the household ID and the TAZ that the household belongs to, and the various household level attributes, mostly pumps attributes and a few others, which are output from the population synthesizer. The person level file, that too has person level attributes from pumps and a few other attributes that are calculated and needed for the ActivitySim model, such as the person type or employment type or student type. final input is the skims matrix. As I mentioned before, we just have one skims matrix in the one skims file in the OMX format. And as you can see, there's just dozens of skim attributes for both highway, non-motorized, and transit modes. And you can see the dimensions are just 25 by 25 because of the 25 zone example that we have loaded. So at this point, I think I'll just go back and run the example, which is fairly easy using the command line interface feature. The command is just ActivitySim run with a few of these inputs as arguments, just the two folders, the configs folder, which has the model configurations and expressions in them, the data folder with the input data from the synthetic population, land use, and skims, and just an output folder that as which is where the outputs are going to be put out after the model sim run. So I'm going to quickly kick this off. It's just going to take about a minute. While we wait, I think I'll just pause for a second to see if there are any questions that it would be good to address at this point, Ben or Joe.
I don't think so. I mean, I think we've been answering most of the questions. If anybody has any questions, go ahead and ask those.
Okay, great, thanks. I will, in that case, just go on to show the multi-processor example. That's right below the example run. So I did not really point to this other config folder called configs_mp. And this is what has the multi-processing settings. I've just, for the current example, I've just kicked it off using a single processor. So you'll see that this just has one additional settings.yaml file. What it's doing is it is inheriting the settings from the main settings.yaml file in the config folder. So this is really a useful feature where you can inherit settings from another settings or configs folder, where if you're trying to experiment with a few additional options, you just don't have to make copies of the original settings file with all the other model expressions in addition to the settings.yaml. So that's what we have in here, the inherit settings flag set to true. And the main overrides for the multiprocessor setting is you want to set the number of processes to begin with. And currently it's just set to 2 in this example, but you can go to as many cores you have available on your computer. And then there's a couple settings related to memory, where based on how much RAM you have, you can specify what's called chunk size. And then there's also which steps you want to use the multiprocessing for. And that's what's shown in the command, just in the multiprocessor example, where you provide 2 config file arguments, both the configs folder and the configs_mp, and it'll combine, the system is going to combine both and run using multiple processes. So the small example, it seems like, has run. It's putting out all the logging statements, and these are also output in the output folder. So I'll quickly go to the output folder to show all these files that have been written out. So all the logging is in the log folder, the log files that you saw in the Jupyter notebook output. And there's a trace folder that for looking at the detailed calculations for the trace households. I'll go into this in a minute. But then there's all these output files that have been created just at the end of this example run. And I will go back to the notebook to look at some of the outputs in detail. So at each stage, after each model step, all of the tables are stored in an HDF5 format file called pipeline. And this gives us the ability to start the model run from any stage, any step in the whole process, which is really convenient. And just looking at the output files quickly, again, there's a households file and a person file. But in addition, there's also a tours file and a trip file. There's also, if you are simulating joint travel, there's a couple additional files to show the outputs of that also. The final households file is just the input file with a few the new output columns or simulated columns added to it. This can include just the total number of tours and trips, any joint tours, but also the auto ownership. We'll look at the outputs in more detail in a second using the summarizing results notebook. But just similarly, person file 2 has the input fields and additionally a bunch of the simulated outputs in here, including work location, school location, as such. And then we have the tours file. We have information about each tour that has been simulated for all the persons and the details of the tours, the main attributes such as the origin, the destination, the tour mode. We also have information about the stop frequency and the tour purpose, etc. We have a similar looking file to go into the details of the trips within each of those tours. There are a few other output files written out. The accessibility calculations are in here also, where for each of the zone, you get the accessibility by mode. All right, and finally, there's the trip matrices that are written out that can be used by the assignment model downstream for assigning. So let us, at this point, maybe quickly look at the tracing feature that's available. We really put out detailed calculations for the trace households, and they are in the trace folder within the output folder. So let's look at a few of them. And for the household ID that we have specified for tracing, every model step, the calculations are output. And you can see how the various utilities are then resulting in the choices made for all the household members. So let me go into just maybe the auto ownership tracing for the household that we traced in this example model. So these are all the auto ownership related trace outputs for the household that we have chosen. And the choosers output provides information on all the attributes of the particular household that have been used in the utility expressions. And then the calculated utility expression values are themselves shown in a separate file. So these correspond to all of the expressions used in the utilities that we have seen from the auto ownership model specification file for this particular household that's being traced. In addition to the expression values, there's also the utilities for each of the alternatives. In this case, it's all the auto ownership alternatives from 0 to 4+. There's also the probabilities calculated based on the utility values, and we can also look at the random number that was generated for simulating the choice, and finally the choice made. In this case, it's just a 0-car household for the household that we have traced. So we have all these trace calculations for each model step. So it's really detailed and useful to debug any problems with the data, to really understand how certain households are choosing or making certain choices. So again, I think at this point, I'd like to pause for 1 second to see if there are any burning questions that need to be addressed.
Well, the question that I was just answering was about, are the accessibilities written out log sums from the destination choice model? So there's two accessibility models, or in a way, there's two types of accessibilities calculated. There's an aggregate accessibilities model that is run at the beginning, and that gives you a user customizable set of expressions to do aggregate accessibility calculations. In addition, the destination and mode choice models both have the option to save the log sums that are calculated. So the mode choice model can save the log sums, and the destination choice model can save the destination log sums as well. That was it.
Great. So I'll also briefly walk us through the second notebook we have on summarizing the results. What I've done for this is I've run a bigger example than just the 100 households that we just simulated. So the results look more reasonable and less sparse. And for that, I've just run the San Francisco County example, I think with a few 100,000 households, which takes longer than the example. But let us look at the results, some of the results of that run using the second notebook recipe for summarizing the results. So we have, we primarily are using the matplotlib Python package to generate the charts, and also GeoPandas and for preparing some maps. So let me go ahead and run this. We have a folder to output the summaries in flat files if you'd like to analyze them later in Excel or some other software. And then there's a few lines of code to load up all the the outputs that we've just looked at, the accessibilities, the households, persons, tours, and trip files. We're also loading in the skims file and the zonal shapefile to prepare the maps. Further down, there is some recoding going on, especially for the person type, where you just have a person type code, 1, 2, 3, that's just converted to a more human understandable label. We've got mode labels also, and just recoding some of those variables. As I mentioned earlier, we have the matplot Python package to display the charts, and just so that we can look at some of these charts within the notebook itself. So the first chart we have here is just the auto ownership, the results of the auto ownership model by household income. And this is just for the San Francisco example that I ran. And you could see how we have the auto ownership category, the number of households in each of the auto ownership categories, 0 through 4+, and the distribution of the household incomes within them. And as you can see that as we have more and more vehicles in the household, the proportion of low income households is decreasing. We also have some code for mapping the average household size at the TAZ level. And again, these are all just very useful Python tools that we are able to leverage because of using the notebooks. And all of these recipes are available to you from these example recipe notebooks that we have created to go along with all the example data. You can see how the average households in the inner downtown area average auto ownership is much lower compared to some of the outer zones in San Francisco. There's several more such summaries. This is the coordinated daily activity pattern by person type. And then going down further, there's just no limit to all the different kinds of summaries that you could do. And as you've seen that Joel and team they have developed a whole calibration validation package in R that you could also leverage. But this is we hope that you could get started on this, using all of these recipe books and create your own templates or set of summaries that would be useful for you. This tour mode choice by the tour purpose, and then trips, and just a lot. I've just taken a sample of these from the actual notebook in the repository. So again, I think at this point, we really hope that you get the sense that this is very straightforward to get into. There's a lot of tools and recipes and example data just readily available for you to get started with this. And with that, I think I would like to turn it back to Joe. If there's any burning questions, we can take them, or just go on to the wrap-up phase.
Thanks, Bhargav. That was super helpful. I'll just offer a couple final slides about some of the work that we're doing that's upcoming, and then open it up. We do have some time for some additional questions for folks that may have, either from the earlier discussion sections or presentations, or from Bhargav's presentation. One of the things that Guy mentioned earlier is that the partners and AMPO will be releasing a procurement within the next week or two to broaden the community of contributors to the ActivitySim project. Thus far, RSG, under contract with AMPO, has been, and more recently with WSP, have been the sole contributors. But we're really excited about, where we are in terms of the development of the project, with all of the kind of core implementation goals and requirements having been met. We're really now at the point of moving forward into kind of newer and uncharted realms. And that really, it's important at this point, not only to have a broader set of folks who are, contributing not only to the code, but also to the ideas and helping to shape what the ActivitySim project is. One of the challenges of the ActivitySim project is, of course, that it is, simultaneously both a kind of a platform and a kind of a technology for implementing travel behavior choice models and other models potentially as well, but also, a set of kind of model systems, a really proven and kind of tried and true product that agencies can pick up and run with and then customize. And so having more people contributing ideas, both about everything from how to implement individual capabilities to how to make sure that we do that, one build, many implementation goal that Clint alluded to earlier in mind, and not just in mind, but in practice is a key challenge. Again, this will be out in the next couple weeks. Be a multi-year contract to do task order-based ActivitySim development. We wanted to leave the last maybe 10 to 15 minutes of of today's tutorial for a general set of questions that people may have. We can go back through the chat, of course, and see if there are any unaddressed questions, but also we did receive some questions a priori, including, for example, and yes, I should have gone into this mode, whether there's any advice, and I would open this up to any of the contributors and speakers from today's presentation, for agencies that are thinking about moving from a traditional model to an activity-based model, what they might want to have on their mind, whether there were barriers. And I'd be interested if agencies themselves perceive there to be barriers in implementing activity-based models. Again, whether any of the contributors can speak to the challenges of maintaining and using an activity-based model, model. And then finally, the challenges associated with using and configuring and developing a common software platform that is both shared as well as able to reflect the kind of unique attributes and aspects of each individual region. So I think I'd maybe like to open it up to the folks who have joined and helped us today, Joel and Clint and Jilan and Guy and others. Maybe if you want to offer some kind of initial thoughts on some of these questions. And then if there are participants who would like to offer additional questions in the chat, I would encourage you to do so. So do we have any takers
Sure.
on these questions?
I'll start off. I think my experience comes from both being on the consultant side and helping regions implement activity-based models, as well as a significant amount of time in the public sector at an MPO, managing and overseeing an activity-based model. And I think both the barrier and the challenge of maintaining and using the activity-based model is I'd really encourage folks who are thinking about transitioning to activity-based models, whether it be ActivitySim or some other activity-based platform, to really seriously consider about how you can bring the knowledge base in-house in terms of running the model, in terms of understanding the model outputs and how to apply those model outputs. I think one of the things that was a challenge at the MPO, and we were blessed to have a pretty big staff where I was, and a very good staff, but as oftentimes in smaller MPOs, it becomes a bit of a black box. And so trying to answer questions becomes a consultant relying on experience. And as a consultant, maybe that's great, but I think we're far better off having MPOs or counties or cities or states, whoever are running these things, understand how the models work mechanically and also the mathematics in the model, so they can not so much track down bugs, I think that's kind of secondary, but really understand the impacts their policy that they're testing or having, because there is a mathematical solution in these models. They aren't just some big black box. And so really having a full detailed understanding of sensitivities throughout the model, how one model affects the next model, I think in-house and really dedicating yourself to have that knowledge base is really important for when a planning director or an executive director comes and asks you a question about why the model does this or that. And then in terms of common software platform, I think it was those of us who've implemented activity-based models early on. I think there was a lot of frayed development around the country in terms of systems being replicated, but then being on their own fork. And both as a consultant, it's hard to maintain because you're not always sure who's got what. And you're trying to figure that out on the fly, but also too, as an MPO or a city or county, you're really trying to, you're paying over and over and over again to solve similar questions. And so I think having a common software platform via ActivitySim or CT-RAMP or DaySim, I think is a really positive step forward. And I think each of those platforms is getting better, but I think that ActivitySim looks to provide the clearest path forward in terms of having a one build many implementations.
Does anyone else want to comment on that from our speakers today?
I would add that I think it's really important that agency staff become familiar with working with disaggregate model outputs. It's a bit of a change in how you approach model results. But you have to keep in mind that these models are producing disaggregate outputs of tours, trips, households, persons, and it takes a bit of training and experience working with these files to understand how the policies or projects that you've tested in the model affect the results. So, getting familiar with Python or R or other statistical packages that allow you to query model results is really important. And anything you can do to, kind of post-process the model results in ways that make it relatively easy to summarize them is really important. I think it's also really important for staff in agencies that haven't been through an activity-based model development project before to be as involved as possible in the development work. Obviously weekly conference calls or bi-weekly conference calls are important, but if staff can contribute in some ways to the development of the data used in the model or the calibration of model components, and if they can take receipt of the model early on in the process while the consultant is still active in developing the model, that's very helpful.
Yeah, and maybe if I can build on both of your comments, thank you, is that, one thing that I have been trying to evangelize a little bit about is that when folks become, active partners of the project, it's not only that you're able to leverage, the resources of all of the other agencies, but you're also able to leverage the knowledge of all of the other agencies. And we do have a wide range of participating agencies at this point, some of whom have been, actively using activity-based models in some cases for almost 20 years now. Others who are really just getting started. This is their first year. And I think there's been a really great and healthy kind of collaboration and sharing of ideas. And so, in terms of kind of shining a light inside the black box and in terms of getting assistance in terms of, as Joel said, maybe it's data development, or maybe it's learning from somebody else's calibration experience. It allows agencies to not just only look to their own internal staff or look to the consultants, but look to their peer agencies across the country as well who are using the same software.
Yeah, Joe, I would say from an NPO perspective, I would say take ownership of your model when you switch from, say, a 4-step to an ABM. Look under the hood real good, but also don't think you're going to switch overnight. There's going to be a transition period of time where you may maintain both at the same time, compare back and forth, make sure you're comfortable, lots of cross-training in-house and otherwise. So that will be my advice.
Yeah, I think they're all well said. I want to add to the first question. Since SEMCOG think about moving from a chip-based model to an activity-based model several years before we finally decide to move to that. So internal staff resource, it's one big question we always ask ourselves. Knowledge-based, how, like, do we have enough knowledge to understand the activity-based model, and do we have a time for that? And I think Joe mentioned that, and that's why we are kind of using two-phase approach. We want ourselves to get familiar with the activity-based model when I3 is still actively developing that. We have questions we can ask them, and we also ask them to develop a staff capacity development plan, kind of for us to get involved in the estimation, at least one model, ask staff to try, estimation, calibration, and even some sensitivity tests, we will be more involved on that. So hoping through all these learning period for different models, we are able to understand more of that and take advantage of the new features from activity-based model. Another thing is, I think we ask ourselves a lot before we move to this, how are we going to use activity-based model differently than we use a 4-step model? So it depends what is your policy planning needs. Do you have a new kind of questions your 4-step model cannot answer? And one last thing is for data preparation. I think at SEMCOG, we thought we have pretty good data, and we have a good land use model. They are in the parcel level. So we think we kind of ready for activity-based model, but when we did get started, we still find some data we need to dig into more and work on that to get that data prepared for activity-based model. That's all from me.
Thank you, Jilan. Well, we're pretty much at the end of our 2 hours. I want to thank all of the folks who participated and presented today. Ben from RSG, Bhargav from San Francisco, Guy from ARC, and Clint from WSP, as well as Jilan from SEMCOG and Joel from RSG. There's a few contacts and links that I put up on this last slide. Bill Kiruz has been, now the executive director at AMPO, has been essential towards helping make this project work. If any of you are interested in talking to him or hearing his experience, he's talked to lots of agencies around it, please don't hesitate to reach out to me. Of course, you can reach out to, to Bill rather. Of course, you can reach out to me and Ben about any of the work that's currently going on with ActivitySim, or as well as any of the other partners. We are going to be posting this. Zephyr Foundation will be posting this, so you'll be able to view a recording of it. If you see in the chat, Elizabeth is also asking us if you could take a few minutes just to fill out the survey. That would be really great. We really appreciate the feedback. And unless there are any other final comments, I think that will wrap it up for today's learning session.
Joe, one other thing to add maybe is agencies other than NPOs can join the AMPO-led consortium too. We have a few.
That's right. The San Francisco County Transportation Authority is in fact not an NPO, but we have been participating for, I think, about 4 or 5 years now. And if you have questions, again, about any of the arrangements or kind of the administrative logistics, with respect to joining the consortium or their procurement or anything, again, don't hesitate to reach out to either Bill or me. All right. Well, with that, I think it's a wrap. Thank you all so much.
Thanks.
Thanks. Bye.